All right, let's work on this assignment. All right, so actually this assignment is ask you to use the relationship between each other to fill in the blanks. All right, so here this is the output for a regression, right? And then we need to decide it is simple regression or multiple regression. How we can decide that? We look at the parameter estimates table, right? So we say that the intercept is always about beta 0, right? And then we have 1, 2, 3, 4 explanatory variables, which is x1, x2, x3, x4, right? And then the corresponding coefficients for x1 will be beta 1, beta 2, beta 3, beta 4, right? So just the actual question. So what is the population model for this regression? Since we are talking about population model, we'll start with mu of y, right, equals to the intercept beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. Right, so this is the population regression model. And then we can use these estimates to find the simple regression equation. All right, okay. So we have 4 explanatory variables, so it is the multiple regression, right? And then for the first column of parameter estimates table will be the corresponding estimates for the betas, which is the value of b's, right? So this is for b0, this is b1, this is b2, this is b3, this is b4, right? And then next column is their corresponding standard error, right? So this is standard error of b0, standard error of b1, and so on. Next column is the t ratio. So what is t ratio? It is the testing about the t-test statistics for testing the betas equals to 0 or betas not equals to 0, right? And then you have the corresponding probability, the p-values, right? So this p-values is to testing about what? About for each betas, right? So for example, this p-value is to test about beta 1, right? So then you will have beta 1 equals 0, beta 1 not equals to 0. And then this is your p-value, right? So testing about for whether this HDL variable is significant in this regression. If it is significant, that means this variable have significant contribution to this model, right? But for some other cases, if the p-value is very big, that means what? Does that mean this variable doesn't have any relationship with the response variable? No, it means with other variables added in the model already, adding this variable into the model doesn't have actual contribution to this regression. All right, so here you need to be careful. All right, so we are kind of done with this table. Let's go up to the next one, which is for ANOVA table, right? Analysis of variance table. All right, so for this table, we have totally 3 rows: the model, for the error, for the total. So what is the relationship between these 3? We say the model plus the error equals to the total, right? So similar idea, we say the first column, the degree of freedom, right? We say the degree of freedom for the model plus the degree of freedom of error equals to the degree of freedom of total, right? So with this regression, with this relationship, we say the model plus the error equals to total, right? So we say for the degree of freedom 4 plus the degree of freedom of error should equals to the degree of freedom of total, which is 441, right? So what is this blank? This blank will equals to 441 minus 4, which is 437. Right? So with this relationship, we can get here is 437. All right. So now we want to use the same relationship to work on this column. This column is for sum of squares, right? So we still have the sum of squares for the model plus sum of squares for the error equals to sum of squares of total. All right, so what is this? What is short for that? SSR, right? This is SSE, right? This is SST, right? So we say the SSR plus SSE equals to SST. And then we say this blank plus this equals to that. Then how you get this blank? Would that just be, we say, yeah, we just do the subtraction, right? So it would be 8608.2310 minus the SSE, which is 5997.7627, will equals to the SSR, right? So which is 2610.4683, right? So here we say here is 2610.4683. Right, so that means we have the SSR plus SSE equals to SST. To get SSR, we use SST minus SSE will be SSR. All right, okay, so next will be the mean square column. So what is this 652.617? How you get this number? This is the SSR divided by the corresponding degree of freedom, right? So you can check if you use this value divide by 4, you should get the same thing here. All right, our problem is to figure out what is this one. What is this? This is MSE, right? So how you can get SSE? The same thing, you use the SSE divide by the corresponding degree of freedom, right? So it will be SSE divided by the degree of freedom. So how you can get that? SSE, which is 5997.7627 divided by the corresponding degree of freedom we have already figured out, right? So which is 437. All right, so what is that? Well, equals to 13.725. All right, so this is MSE, which is should be 13.725. All right, the last column, the F ratio, which is the F test statistics, right? Still remember what is the formula for F test statistics? A equals to MSR divided by MSE, right? So in this table, it is easy to see the F ratio is just the MSR divided by MSE, right? So which is 652.617 divided by 13.725. right? So if you calculate this, will equals to 47.55. All right, so when we learn about this table, we are done with this table, right? So we are done with filling out these blanks. All right, so next will be the top table here, which is the summary of fit table. So the summary of fit table will tell you the general information about this multiple regression. So first it is R square, right? Okay, so we need to know how to get the R square. We say R square is defined as the proportion of variation in y that is accounted by the regression, right? So we have the formula of R square, which is the proportion of the regression in the total, right? So what is SSR? How to find these two? In the ANOVA table, right? So we say SSR is the one we calculated, SST is the total, right? So we have 2610.4683 divided by 86.82310. All right, so if you calculate this, you should have R squared equals to 0.3033. All right, done. So next one, adjusted R square. So what is adjusted R square? Adjusted R square is the R square you want to use to compare models, right? R square will tell you how well is this model, but when you want to compare the models, you need to use adjusted R square, right? So for let me change to another color to make it clear. Okay, so adjusted R square has also its own formula, right? So we say adjusted R square equals to 1 minus R squared times n minus 1 divided by n minus k minus 1, right? So which is 1 minus R squared, 3.3033 times n minus 1. Okay, now we need the n, right? So how to find the n? We say, what is the degree of freedom here? The degree of freedom of model equals to how many variables, how many explanatory variables in your regression. So here we have 1, 2, 3, 4. So that's why the degree of freedom is 4, right? And then we say, what is the degree of freedom for the error? We have the formula, which is n minus k minus 1, right? What is the degree of freedom for the total? It is n minus 1. Right? So since n minus 1 is 441, so what is n? Will be 442, right? So now we can figure out here, observations is the n, right? So it would be 442. All right, so now we find n, which is 442 divided by n minus k minus 1. So what is n minus k minus 1? Wait, yeah. So n minus 1 is just this, right? So it will be just a 441 divided by n minus k minus 1, which is the degree of freedom of error, which is 437. Right, so if you calculate this, will be equals to 0.2969. All right, so this is adjusted R squared, which is 0.2969. All right, some of you asked me about it doesn't look right for here because adjusted R square kind of smaller than the R square. It is normal. All right, so that means what? That means you are adding some variables, kind of repeated information, so that's why your adjusted R square decreased. Remember that when we add any variable into our regression, the R square will be increased, right? It doesn't matter this variable is useful or not useful, the R square will always change, will always increase. All right, that's why we do not use the R square to compare the models with different number of variables. We need to use adjusted R square, right? So adjusted R square is kind of a penalty to adding more variables into the regression. If the variable is not useful, you will see the adjusted R square is decreased, right? So just trust yourself. It is normal to see the adjusted R square is smaller than the R square. All right, so we have one more blank, right? So which is the root mean square error. So what is the root mean square error? First, it is SE, right? Okay, so what is SE? SE is the standard deviation of the residual. And also we have the SE is just the square root of MSE, because MSE is mean square error, right? This is root mean square error, right? So since we have the MSE, which is 13.725, so you just calculate, right? So what is that? It is 3.705. All right, done. Okay, yes, we have one more here, the t-test statistics, right? For testing about the betas, right? So here we say the t-test statistics with the formula, which is B1 divided by the standard error of B1, right? So this is for the B1, right? So this blank is for the B1. So how to calculate the test statistics? We'll use the B1, which is negative 0.097587, right? Divided by the standard error of B1, which is this, right? So it will be 0.014432, right? So if you calculate this, it will be negative 6.76. That's it. All right, so actually, if you want to fill in the blanks, you need to get the relationship between each other. All right, so there are kind of complex relationships between these numbers, but at least as long as you can find the relationship, it is easy to fill in these blanks. All right. In your exam, it is also possible to make this blank or the other blanks. It will not be just these ones. All right, so you need to totally understand the relationship so that it doesn't matter which one I make a blank, you can always find the relationship. All right, so I think this is enough for this assignment. Next video, I will talk about the assignment 8, which is a much longer one. All right.